What's up YouTube? It's your boy, Learn Things Have Fun. We are jumping right back in with some indices. This time we're looking at negative indices, and we're also looking at fractional indices. More indices than you could ever need in your life. By the end of this video, you're gonna say, oh damn, I love indices. Okay, so we're gonna get started. We're gonna look at some negative indices. We've got two rules that we're gonna learn. The first is this: any number raised to the power of minus m is equivalent to 1 divided by a to the power m. Let's see that in action. So that means that if I had, for example, this 2 to the power minus 1 down below here, that is the same as saying 1 over 2. If I have 2 to the power minus 2, that is the same as saying 1 over 2 squared, or for the purposes of this, I'm going to call that 2 times 2, or 2 to the power minus 3. Think what that's going to be. Correct. It's going to be 1 over 2 cubed, okay, which is 2 times 2 times 2. Now, why have I written it in a slightly strange way with listing every single number out instead of just using the power? It's because of the second rule. This second rule is a little bit unintuitive. Anything to the power 0 is 1. But why? Why? Here's an analogy, and it's not a perfect analogy, but we see that as we increase the power of our number, we're taking 1 and we're multiplying it by our number many more times. So 2 to the power 1 is 1 times 2, 2 squared is 1 times 2 times 2, and if we go the other way, we're taking 1 and we're dividing it by 2 many more times. So 1 over 2, 1 over 2 times 2, but then at this little middle point in the middle, 2 to the power 1, we just have 1 by itself. We're not multiplying it and we're not dividing it. It's sort of like a balance point on a seesaw. So that is how I like to visualize this. It's sort of this little balance point. If that helps you, that helps you. If not, just accept the rule. Anything to the power 0 is 1. Okay, let's jump in and let's start using these exciting new rules. So the first thing is that obviously maths builds on itself. Okay, so we're not going to throw out everything that we've already seen. We know, okay, that if I have x's to the powers multiplied by each other, I'm going to go ahead and add those powers. So let's look at this one on the far left. X cubed multiplied by x to the power of minus 1. I'm going to add them. My answer is going to be x to the power of 3 plus minus 1, which is x squared. This also gives us new eyes to think about one of the problems we did in the last lesson. In the last lesson, we did work this out by doing x to the 5 minus 2, and so the answer here is x cubed. We can see it in a little bit more rich detail why this is the case now. We know that x to the power 5 over x squared is equivalent to this lovely little expression over here, okay, x to the 5 multiplied by x squared to the minus 1. We've used this property where to the minus 1 is equivalent to it being 1 over. If I multiply through those powers, so I have minus 1 times 2, I can see that this is also equivalent to x to the 5 multiplied by x to the minus 2. And now, when we follow the very basic rule about indices, we're going to add those powers. So I'm going to have x to the power of 5 plus minus 2, x to the 3. So we can get a better understanding of why this thing works to begin with. Isn't that interesting and exciting? Let's look at some other examples. Okay, here we go. In these two cases, we have to be a little bit more careful. Let's look at the index of our denominator, okay? It's a minus 3. Now, have a think about this. I'm going to rewrite this to bring the denominator up. So I'll just have a numerator, or remove the fraction, I should say. So have a think about this. It's going to be x cubed multiplied by what? Yes, that's going to be x cubed as well. As I bring this up, let's do some intermediary steps. So x cubed, as I bring this up, I'm going to say this is x to the minus 3 to the power of minus 1. Okay, these are two equivalent statements. And as I multiply these ones out, this minus 3 and minus 1, this just gives me x cubed. Those two negatives cancel out there. So the answer to this question is actually going to be adding them up, x to the power 6. Ooh, look at that. And we're going to do the exact same thing over here, and we're going to try and be as careful as we can. Let me get myself in some space here. The first thing we're going to do is split this fraction up. So that's going to be 2x squared over x to the power minus 5 minus x over x to the power minus 5. Have a think about, maybe pause the video, What's it going to be when I bring these numbers up? Well, it's going to be 2x squared multiplied by x to the power of, should we do the intermediary steps? So let's go minus 5 to the power of minus 1 minus x to the power of x to the power of minus 5 to the power of minus 1, okay, which therefore equals 2x squared x to the 5 minus x to the 5. Okay, so now all I have to do is go through and add the powers in the normal way. So I have 2x to the 7 minus x to the 6. Okay, so let's just be careful with these, and remember when we bring them up, these two negatives are going to cancel and we're going to end up with positive indexes. Happy days. Right, now we've already looked at this in some ways. We know that the rule is when I have something raised to a power, okay, I have to multiply these two indexes together. So this is going to be x to the power of 3 multiplied by minus 1 minus 3. And I can actually rewrite that using the rule to say that's 1 over x cubed. And that's much neater than this, because that's nonsense. Okay, let's look at this one. What we're going to do is we're going to split this one up into two parts, and we're going to apply that index to both parts. So I'm going to go ahead and say that this is 4 to the power of minus 2 multiplied by x squared to the power of minus 2. Now, there's a little 1 there, which we ignore most of the time. So I'm going to go through and I'm going to multiply in each case. So that's going to become 4 to the power of minus 2 multiplied by x to the power of minus 4. Now we can use the rule to simplify this. So I know if there's a negative power, that's the same as 1 over that number with the index positive. So I can rewrite that one. I'm going to go right here. I'm going to say that's 1 over 4 squared multiplied by 1 over x to the power of 4. Okay, so then my last answer is just 1 over 16x4. Okay, so we apply the power to both parts, we use the 1 over rule, and we have something neat emerging at the end. Fractions. Let's look at fractions. So with fractions, they add a nice little layer of interest to these problems. Let's look at this first one. 2/5 squared. Now we're not going to use any wacky rules, we're just going to crank the handle on it. Now I know that 2/5 squared is going to be 2/5 multiplied by 2/5. Okay, that's just from the definition of a square, right? Now if I was to calculate this, that would be 2 squared, 2 times 2, over 5 squared, 5 times 5. So what have we actually done there? Well, what we've done really is we've applied this index to both the numerator and the denominator. So that is our rule for dealing with fractions raised to powers, in that we can apply that power to both the numerator and the denominator, crankety crank the handle, figure things out, okay? So obviously that's going to be, wrong pen, 4 over 25. Okay, now when we have a negative power, we're going to do the exact same thing, okay? So that's going to be 3 to the power of minus 1 over 4 to the power of minus 1. Now, we can actually change this around a little bit, so that's going to be 3 to the power of minus 1, and I'm going to call this multiplied by 4 to the power of minus 1 to the power of minus 1. I've just brought it up using that definition. Now, if we were to multiply through here, okay, I would end up with 3 to the power of minus 1 times by 4 to the power of 1. And last but not least, I can rewrite this thing again, okay? That 3 to the power of minus 1, how can I rewrite that? I can rewrite that as 4 over 3. That minus 1 power is bringing it down into the denominator. So what have we actually done? What have we achieved moving from here to here? Well, by applying the power to each individual little bit, the numerator and the denominator, and following that through, we've seen that this power minus 1 has effectively worked to flip our fraction over. So that's a really good shortcut for dealing with these negative powers applied to fractions. All we have to do is to get rid of or to apply that negative, we just flip the fraction. So have a think about this one. Instead of doing all of this legwork, I'm just going to go straight to the answer here and say that 1/8 to the power of minus 1, I'm going to flipperino that fraction, is going to be 8 over 1, which is just 8, obviously. Happy days. And this holds true even when the fractions appear a little bit more complicated, okay? So For example, let's do this first one the long way. So I'm going to apply that power to both. So I'm going to go 1 to the power of minus 2, over 5 to the power of minus 2. Okay, so that's 1 to the power of minus 2 multiplied by 5 to the power of minus 2, and then because I've raised it up, I put that minus 1 in there. So then that's going to be 5 squared, and then to multiply by 1 to the power of minus 2, which is the same as saying 5 squared over 1 squared. Okay, so I've just flipped it and applied the power. So that's going to be 25. The quicker way of doing that is this, okay? So that's one way. We follow every single step. Another way is this, okay? I flip the fraction first, and I say 5 over 1 squared, and my negative is gone. My negative has performed its action by flipping that fraction. And this is a much more simple picture, because all I have to do now is exactly like the first case, is I apply that positive power to both the numerator and the denominator, and everything's easy peasy, okay? So that's just going to be 5 squared over 1 squared, which is 25 over 1, equals 25, okay? So I'm going to do the same process here, okay? I'm going to firstly get rid of that negative, okay? I'm going to say that this is, I'm going to say this is 7 over 2 to the power of 3, which is going to equal 7 cubed over 2 cubed, 7 times 7 times 7, so we have 343, there you go. 343 over 2 times 2 times 2, which is 8. 343 over 8 divided by 8 is 42.9. We'll just call that 42.9. Last but not least, we'll try this one. Have a think about how you do this one. I think we get the idea of this now. So I'll give it the old flipperino, 3 over 2 to the power of 4. I'm going to apply that power to both the numerator and the denominator. So that becomes 3 to the power of 4 over 2 to the power of 4. Okay, so I think that's 81 over 2 times 2 is 4 times 2 is 8 times 2 is 16. 16. 3 to the power of 4, is that 81? 3 to the power 4 is 81. Good. 81 divided by 16 is, oops, syntax error. 5.1. We'll round that to equals 5.1. Okay. There you go. So we have looked at negative indices. We're going to bring it home and we're going to look at some fractional indices. So this is going to round off the chapter and give us a good understanding of all the different types of indices that we might see. Okay, so we've got a new rule, and this is that rule. Here we go. If I have a number raised to a fraction n over m, that is equivalent to the mth root of a raised to the power of n, which is also equivalent to, so we can raise that whole root to the power of n, or I can take the mth root of a and raise a itself to the power of n. So these two statements are equivalent. Okay, so let's start by having a look at these fractional indices. Okay, so as is almost always the case, the normal rules still apply. Okay, so we haven't thrown anything out just because we're looking at slightly different structures. Okay, so here we go. I have x to the half and x to the 3 halves. What am I going to do? Add them. It's a bit like Dora the Explorer, okay? Call and response. I hope you're yelling at the screen when I'm posing these questions. So we're going to add these, okay? So that's 1 half, so that's going to be x to the power of 1 half plus 3 halves, which is going to be x to the power of 4 halves, which is of course x squared. Okay, with this one, we're going to follow our exactly normal rules. Okay, remember we have to multiply the exponent of x and what it's raised to here. So that's going to be x to the power of 3 times 1/4, which is 3/4. Okay, so the normal business of indices still apply. What we can do is this. So we can write things in an index form, which is a number raised to a fractional index. And we can also write things over here in terms of square roots being raised to their own powers, okay? And sometimes it's more useful to be in index form, sometimes it's more useful to be in root form, and we can go from one to the other, okay? So let's have a look at this one. So x to the power of 2/3. Okay, So looking at the rule, I know that is going to be the cube root, wrong pen, the cube root of x squared. Okay, or I could say the cube root of x squared like this. Those are both equivalent. 9 to the power 1/2, okay, that's going to be the square root of 9, which is, of course, 3. 16 to the power of 3/2, that's going to be the square root of 16 raised to the power 3. Okay, so the square root of 16 is, of course, 4. 4 raised to the power 3. 4 times 4 is 16, times 4, I believe, is 64. So 64 times 4, 64, good, equals 64. Okay, having a look at this one, of course, we're going to have to apply that power to each component of this. So that's going to become 4 to the power of 1/2 multiplied by x to the power 1 multiplied by the power of 1/2. So if we just crank the handle on these, that's going to be square root 4, okay, because that's the tooth root, multiplied by 1 multiplied by 1/2 is going to be x to the power of 1/2, okay. Square root 4 is 2, okay, so that becomes 2x to the 1/2. Not the best 2 in the world. There you go. Right. This one, same deal. Okay, we're going to apply the powers to each in turn. So that's 2 to the power of 3 over 2 multiplied by x squared to the power of 3 over 2. Let's work this first one out. So that's going to be square root 2 raised to the power 3. And this is going to be, I'm going to have x to the power of multiplying 3/2 and 2 gives me 6/2, which is going to be 3, okay? We can massage this a little bit, so that's root 2 times root 2 times root 2. Root 2 times root 2 is just 2, so that's going to be 2 root 2x cubed. 2 root 2x cubed is my new rap name. Okay, so we can go backwards the other way, okay? So we can be in a root form, a little bit zoomed out there, but we can go from a root form back to an index form. Okay, so I know if it's a square root, that's going to have a denominator of 2, and I see that the power here is 3, okay, so that's going to be x to the power of 3 over 2. Now, in this case, I've got two little bits, right? So what I'm going to do is this. I'm going to rewrite this as, I know the arrow is going that way, but I'm so used to working left to right, we're going to go this way. So that's 125 multiplied by x to the 6, all raised to the power of 1/3, okay? That cube root is the same as raising something to the power of 1/3. I can distribute that power, okay, so that's 125 to the power of 1/3 multiplied by x to the 6 to the power of 1/3, okay? So I'm actually going back to root form here, but I'm just saying cube root of 125 is 5, so that's 5 there. And then we're going to multiply through here, so that is 6 times 1/3 is going to be 6/3, which is x squared. Okay, so this over here is 5x squared, 5x squared. We're going to do the exact same thing here, so we're going to say that is 64x squared all to the power of 1/3. I'm going to distribute that power, so that's 64 to the power of 1/3 multiplied by x squared to the power of 1/3. Cube root 64 is 4, and x times 2 times 1/3 is 2/3, so that's 4x to the 2/3. And let me put that there so that my OCD is satisfied. So there you have it. We go from root form to index form to root form. Okay. And is that it? That is it. So I'm just going to look at some miscellaneous worked problems. You can give them a go first and then compare answers with me, or you can just watch me do it. These are all taken from exercise, I think 1D in the pure Edexcel textbook. So why not have a go at that exercise, come back, see if you agree. Okay, here we go. So, 4 to the power of minus 2, okay? Using our rule, we're going to say that's 1 over 4 squared, which is 1 over 16. 6/5 to the power of minus 1, okay? We know that the power of minus 1 flips those fractions, that's going to be 5/6. Here we go, 25 over 16 to the power of 3 over 2. I can apply that power to the top and the bottom, so that's 3 over 2 over 16 to the power of 3 over 2, which is the same as saying square root 25 cubed over square root 16 cubed. Square root 25 is 5, so that's 5 cubed over square root 16 is 4, so that's 4 cubed. I think that's 125. We already did this one, 4 times 4 times 4, I think 64. Yes, it is 64. 64, 125 divided by 64, 125 divided by 64 gives us 1.95. 0.95. Let's have a look at this one. Okay, the first thing I'm going to do is I'm going to action that negative power. So I'm going to say this is equal to, I'm going to flip 512 over 343 to the power of 2/3. Then what I'm going to do is I'm going to apply that index to both the numerator and the denominator. So that's 512 to the power of 2/3 over 343 to the power of 2/3. Okay, so applying that index, I can say that's the cube root of 512 squared over the cube root of 343 squared. That doesn't look like a nice number to me, so I'm just going to go straight in the calculator and just do that directly, because what the hell is the cube root of 512? I don't know. So if we go here, we can go, where is my custom cube root? So I think I've got to go home, toolbox, no, I go calculate, toolbox, cube root, here you go, cube root of 512, and I want to square all of that. So that's 64 as my numerator, 64. And I'm going to repeat that process. So the cube root of, nope, excuse me, sorry, typing is hard. Cube root of, I forget, short-term memory, 343, and we're going to square that. 343, bracket squared, 49. Good, so then 64 divided by 49, let's see if that simplifies at all. It doesn't really. 1.306, so that's over 49, 1.306. Okay, next one, here we go. 4/9 multiplied by x to the 4. Okay, so the first step I'm going to do is I'm going to split this up and I'm going to apply that power to both of the multipliers here. So 3 over 2 times by x to the 4 to the power of 3 over 2. Okay, so let's just deal with the x first, because that's probably the simplest one. So that's going to be x to the power of 3 times 4 is 12, divided by 2 is 6, okay? Let's leave that there while we deal with this other thing. So we've got, I'm going to apply that power to both the numerator and the denominator. So that's 4 over 9, 3 over 2, 3 over 2. Okay, so that's going to be square root 4 raised to the power of 3 over square root 9 raised to the power of 3. Okay, so that's going to be 2 cubed over 3 cubed. 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. 3 times 3 is 9, times 3 is 27. Okay, so the final answer is going to be 8 over 27x to the power of 6. Last but not last, we got 2 more. So here we go. 5x plus 3x squared over 15x cubed. I'm not even going to use any of the new rules that we've got here. I think I'm running out of battery, so we'll try and go quick. And we don't have a lot of recording time left, so we'll go quick. I'm going to split this up. This becomes 5x over 15x cubed plus 3x squared over 15x cubed. Okay, I'm going to look for common factors here, so I think there's a 5 and an x is my common factor, which leaves 1 on the numerator. 5x on the bottom leaves me 3x squared. So this first fraction, after these cancel, become 1 over 3x squared, plus, I think we have a common factor of 3x squared here. 3x squared multiplied by 1 over 3x squared multiplied by 5x. Yes, cancel, cancel. So that's 1 over 3x squared plus 1 over 5x. You could make a common denominator and make that neater, but let's not. Here we go. Last question before my camera dies. Given that y equals 1/8 x cubed, express y to the power of 1/3 in the form kxn. Let's do it. Okay, 1 over 8 x cubed raised, which is y. So this is y raised to the power of 1/3 raised to the power of 1/3. Okay, so that's all I've done. I'm going to distribute this power, so that's 1/8 to the power of 1/3, and then that's going to be multiplied by x cubed to the power of 1/3. My x is going to be the easy bit, so 1/3 times 3 is 3/3, so that's going to give me x to the power of 1. And I'm now going to apply that power to both the numerator and the denominator. So that's 1 to the power of 1/3 over 8 to the power of 1/3. Okay, so that's going to be, I'm just going to isolate this and look at it individually for a second. So that's going to be cube root 1, which equals 1. And then I've got cube root 8, which equals 2. So this becomes 1 over 2, yes, 2 times, yes, x. There we go. So my k equals 1/2, n equals 1. I hope that helped. I think my camera's about to die. Not die, but run out of battery. Plenty more where that came from. Let me know. Too casual, not casual enough. We'll do whatever. So listen, maths is fun. Keep learning maths. Pow, 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 pow. Keep winning. Peace and love.